Now looking into the approximate equivalent circuit, let's look at the theories behind it first. So if you look at the diagram for the approximate equivalent circuit referred to the primary side, the diagram look like this, where previously di sini kamu ada R1 and X1, while di sini kamu ada R2 prime and X2 prime. Now the diagrams looks different, where you do not have R1 di sini and you do not have X2 prime and R2 prime here. So let's look at the theories behind it. Why does it happen? Why kamu punya circuit jadi macam mana? Okay, so if you look at the approximate equivalent circuit, the magnitude of the no-load current is very small compared to the rated primary current. So di sini dia bagi tahu that the I/O di sini is very small compared to dengan I1. As a result, there is a negligible voltage drop due to R1 and X1. Without any serious error in the calculation, it can be assumed that the voltage drop across the no-load circuit is the same as the applied voltage. So if you look at this diagram, apa maksudnya di sini? So let's say for example di sini tadi kamu ada R1 and X1. Since the voltage drop across this point is very small, so it's like there is no current masuk kemari because it is very small. It's really small, like there is no voltage drop across this point. So ia mention tadi the voltage across this point, this point A and point B, is the same as the source voltage. So if you look at this diagram yang tadi di sini, like this diagram, it is like this whole thing is shifted to here, and then simplify-nya saja the resistance, which ia jadi macam series. So let's say di sini kamu punya resistance R1, X1, R2, X2, and then di sini kamu punya load. So this is on R1, X1, R2 prime, X2 prime. So this is your ZL prime. Di sini is kamu punya I/O. So ia ada mention tadi yang the voltage drop across the point A to point B is equivalent to dengan the source voltage. So it is like ia shift this one to the left, and then dijadikannya saja this R1, X1, R2 and X2 is in series. So it becomes in series since the current going to the RO and XO is very small, so macam there is no voltage drop across it. So that's why they come to conclusion that the approximate equivalent circuit can be drawn by shifting the no-load circuit across V1. By shifting, tadi as I mentioned, the approximate equivalent circuit is referred to the primary is shown in figure 3.15. The total resistance referred to the primary is, so di sini the whole thing jadi RO1. So RO1 is equal to R1 plus R2 prime. If you look at di sini, you can total up this resistance with R1 and R2 prime. So RO1 is equal to R1 plus R2 prime, and XO1 is equal to X1 plus X2 prime. So di sini kamu punya XO1 is equal to X1 plus X2 prime. So the total up of the impedance referred to the primary is Z01 is equal to R01 plus JX01. So if you want to calculate the RO, since the voltage drop across this point is the same as the supply voltage, so A to B, so if you want to calculate RO using the Ohm's law, so V1 equal to RO I W. So if you want to find RO is equal to V1 divided by IW, where you can calculate IW is equal to IO cos phi naught. You need to refer back on the previous formula on how to calculate IW sama IM. So if you look at this diagram, sama juga, but this time the approximate equivalent circuit is referred to the secondary side, where all of the parameters yang di sini is transfer into the secondary side. So you need to check back on the previous lecture on how to transfer from the primary to secondary and secondary to primary. So if you look at the equation, RO2 is equal to R2 plus R1 prime, and XO2 is equal to X2 plus X1 prime, and then ZO2 is equal to RO2 plus JXO2. So now let's look at an example di sini, 3.6, where you have a 200 kVA transformer. So this is dia punya power rating, and this is the primary side and this is the secondary side. The primary resistance R1 equal to 3 ohm and the primary reactance is equal to 12 ohm. At the secondary side, the resistance equal to 0.3 ohms and the reactance at the secondary side is equal to 0.1 ohm. Now you need to calculate the equivalent impedance referred to the primary and secondary. So di sini ia suruh kamu cari Z01 sama cari Z02. So if you look back on kamu punya equation, approximate equivalent circuit di sini, on how to calculate RO1 and XO1, so it is only the addition or summation of the R1 di sini and R2 prime for referring to the primary. So this is your R1, O1, and this is your XO2. XO1. So looking at this example, first, in order to use the rules for referring to impedance, you require a turns ratio. So how to calculate the turns ratio? Information di sini is given, where V1 and the V2 is provided. So A is equal to V1 divided by V2, you get 5. And then the total resistance referred to the primary side, so RO1 is equal to R1 plus A square R2, you get 10.5. XO1 is equal to X1 plus A square X2, then you get 14.5. So if you total up, ZO1 is equal to 10.5 plus J 14.5. So if you have the calculator that can convert this one straight away from rectangular to polar, you can get the magnitude of the impedance. ZO1 is equal to 17.9 ohms. So similarly to the calculate the impedance referred to the secondary side, first you need to know what is RO2. You get 0.42, and then XO2 is equal to 0.58. So ZO2 is equal to 0.42 plus J 0.58. So if you convert this one to polar, you can get the Z and the angle. So this is your punya Z. So you can try the drill exercise 3.6 for your practice. So that is the end of our lecture for week number 1. We will continue on for week number 2 on the voltage regulation. We will continue on the voltage regulation, efficiency, transformer test, all-day efficiency, and auto transformer. To summarize all of the lecture for today, for this week lesson, first you are looking into the transformer at no load, where you can calculate where the transformer at no load you have two component, which is the working component and magnetizing component, or you can call it working current and magnetizing current. So you can calculate these two, and you know that during an no load condition, the transformer is open circuit, so you can calculate I/O. So I/O, you have two methods to calculate, either using this one or using the power equation. Depends on the information you are given. So if you look at this example, which you have watched on the previous lecture, and then rules for referring impedance, we have covered this one. Why do we need the rules for referring impedance? Is because we want to have the equivalent circuit like this one. This is the original circuit, the two winding transformer, and then we have the equivalent circuit di sini. Why do we need the rules for impedance? Is we want to transfer all the secondary parameters to the primary side. So ia jadi macam ni, R2 prime, X2 prime, and V2 prime. So we have two equivalent circuit, where you have exact equivalent circuit, and then you also have the approximate equivalent circuit. And then finally, we already cover the transformer under loaded condition. Under loaded condition means that the secondary side has a load impedance. So during this time, we want to know what is the primary current when the transformer is loaded. So there is a derivation on how to calculate I1. So in the end, the formula to calculate I1 is this one. So you can practice again by doing the example 3.5 and the drill exercise 3.5, and you may also try the exercise problem at the back of the at the end of this topic, which is the transformer and per unit system. Okay, so that's all for my lecture for this week. Assalamualaikum, and have a good rest.